Welcome to the course Digital Transformation and Technological Innovation. So, we are into our third module, that is transitions in software markets. So, let us continue the discussion from where we left in the last session. So, in the last session we were talking about the virtualization and how it enables cloud computing, and we talked about the three core components of virtualization, that is the host guest operating system, that is virtual machine, right, and the last one, right. So, with all those three core components, now we move on to the other aspects of it. What are the benefits or how virtualization is actually supporting different aspects of cloud computing, what are the kind of things where virtualization is helping the cloud providers. We will look at that. So, first is resource efficiency. So, virtualization actually helps in terms of improving the resource efficiency, because for the same server you would be able to create more virtual machines, and hypervisor is there as the third component. So, you would be using that you can create a scalable asset, on demand scalable asset. So, therefore, resource efficiency will go up. So, same thing is mentioned here, that to pack dozens of workload onto one machine, maximizing hardware use instead of one server running at a lower capacity. So, through virtualization we are able to pack dozens of workloads onto one machine, because we are creating virtual machines which can be given to each end user. They will be running their own applications. So, therefore, hardware use that is maximized to a good extent, and in comparison to a case where one server is running at a lower capacity, maybe just one application. Instead of that one server is supporting lots of VMs through virtualization, and therefore, lot more workload is running, and therefore, hardware use is maximized. So, resource efficiency is much better. So, with the cloud computing, resource efficiency for overall computing that is there across organization, that becomes more resource efficient. So, therefore, there is a economy wide, nationwide and globally much more resource efficient usage of computing because of the cloud, right. So, overall if everybody is opting for cloud, then overall we would have lower requirement for physical servers, right. Then the next important aspect is scalability and agility, right. So, because of the virtualization you can quickly spin up a new virtual server, right, new virtual machine, because hypervisor is there which is managing all the abstraction. So, we already said on demand scalable assets we are able to create. So, we can quickly spin up a new virtual machine in minutes or second without needing to install physical hardware, right. If you were to scale in a more physical sense, then you will have to buy a new server, get that installed, do all that setup. But here all that is not needed, because of the resource efficiency. Virtualization will allow will easily facilitate another VM to be created, and whenever needed, whenever scalability or agility is needed, we can quickly spin up a new virtual server in minutes or seconds. So, therefore, scalability and agility is another important aspects that is very well supported by the virtualization. Next is isolation and security, right. Now, to isolate one user's VM from another's in a shared physical box, right. So, virtualization helps that isolation, right. It creates that abstraction, it makes sure that one user's VM does not interfere with the another one, because both are running, both might be running, may or may not be running on the same physical box. So, even if they are running in the same physical box, virtualization will ensure that one user's VM does not interfere with the another ones, right. So, in this fashion that protecting one VM from a crash that might happen, or malware infection that might happen on other virtual machine. So, if one virtual machine gets infected for some reason, the other virtual machine, other users and their virtual machine will remain protected because of the virtualization. So, this isolation and security via isolation is actually supported because of the virtualization software. Then if we look at the disaster recovery, then virtualization can help cloud providers to easily back up take snapshot and move VMs between physical servers for quick recovery, right. So, VMs are essentially files themselves, right. So, essentially in a way they can be quickly backed up just like files, and snapshots can be taken and they can be quickly moved from one server to another. So, that quick recovery can be very quickly facilitated in case of cloud because of the virtualization. So, disaster recovery is also quite well supported. So, overall 24/7 availability or high availability is also in a way supported because of the virtualization, because users are working with virtual machines, virtual computers. Now, what is the virtualization impact with all these aspects, with all these factors that we just talked about in terms of resource efficiency, better utilization of computing, scalability, we can quickly get a machine, virtual machine rather up and running, isolation, disturbance of one user's to another user's work, and isolation and security and the disaster. With all these, what is the impact that virtualization is having? So, first is the hardware needs of organization that go down, right. So, if you were to run two applications in a traditional setup, maybe you will like to have two separate servers running those applications, so that those applications do not interfere with each other's data and run in a more segregated, separated way, so that more availability of those services could be ensured and other factors. So, virtualization reduces that need. You do not need to have two separate physical servers to run two applications in a separate way. Virtualization gives that isolation, and therefore, the hardware needs. So, the same server can be used to support those two applications via virtual machines. So, essentially the hardware need of organization can be reduced because of that, right. Then virtualization also powers the organizations to create their own private cloud, right. So, instead of all of us are users of public cloud from Google, Amazon and Microsoft and other firms, other cloud providers, but organizations for some reason if they cannot use the public cloud, they do not need to miss out on the strength of virtualization, all the aspects in terms of resource efficiency, scalability, isolation, disaster recovery, security, all that we talked about. So, they do not need to lose on all these advantages that virtualization or cloud technology gives. They can convert their on-prem technology infrastructure, on-prem data centers into private cloud, right, and therefore, they can create their own private cloud of scalable assets. That is why in the earlier session we are also talking about the hybrid cloud scenario, where you have the private cloud or on-prem and you also have the public cloud. So, virtualization actually powers the organizations to create their own private cloud of scalable assets, right. So, this is another impact of virtualization. Then cuts energy consumption, because maybe you are running just one server and multiple VMs, you are not running multiple servers. So, therefore, you do not need to power multiple servers, you are just powering one server managing multiple VMs, right. So, therefore, energy consumption goes down, and for the same reason carbon footprint also that is lowered, right. So, virtualization, as I talked about, that it has an impact at the firm level, but it also has an impact at the industry level, economy level, country level and at the globe level. Overall energy consumption worldwide will go down, overall carbon footprint will go down, and overall resource efficiency will go up if we adopt cloud computing technologies for the private cloud or for the public cloud. Moving on, now we have already talked about one type of virtualization technology, or when we say the word virtualization, we essentially are talking about virtual machine, right. But there are other types of virtualization technologies also. So, again let us reframe what we meant by virtual machines. We have already discussed reframing here. So, this is a virtualization technology that virtualizes the physical hardware to run isolated instances of a full guest operating system for each VM, right. So, for each virtual machine a full guest operating system is run, and isolated instances of full operating system are run for each VM using the same physical hardware. So, virtualization allows us to use the same physical hardware to run multiple isolated instances having full guest operating system for each VM. So, that was about virtualization machine or main virtualization technology. But then there is another virtualization technology that is referred as containers. So, containers this is also a virtualization technology that virtualizes the operating system. So, virtual machine, we are talking about the virtualization of the physical hardware, right. So, in VM we virtualize the physical hardware, in case of container we virtualize the operating system. So, this is a virtualization technology that virtualizes the operating system while sharing the host kernel. Just like in case of virtual machine, the same physical hardware is shared, the host kernel is is shared in case of containers, but other layers are changed to virtualize the operating system, and then we run isolated processes for each application, right. So, idea is to run applications in an isolated fashion while virtualizing the operating system, right. So, we can run, because of this we can run multiple containers, that means multiple applications on the same machine, right. So, this is another level of virtualization that can be achieved, right. So, it is in a way more efficient than what we can achieve via virtual machines, right. Now, further elaborating on container. So, container is a lightweight standalone software package, right. So, essentially when we say container, we are talking about a software, we are talking about an application. So, it is a lightweight standalone software package that bundles the application's code, whatever is the functionality that is to be executed based on input, right. So, that bundles an application's code with all the dependencies, libraries, dependencies and configuration files, right, needed to run consistently in any environment with matching OS. So, any environment where a matching OS is there, because we are packing in the libraries and dependencies. So, that should match, only then we will be able to run it, right. Obviously, we can create multiple containers for different OS, right. So, essentially this is another elaboration of what we mean by container. So, this is also an application, this is a lightweight standalone software package, and apart from the application's code, all the libraries dependencies are also packed in, configuration file, everything is packed in. So, you can quickly run it just like another application, right. You quickly run it, and it can run consistently in any environment. So, and only thing that we need to look at, that matching OS has to be there. Now, what are the core components of containers? So, first is container image. So, what is container image? So, this is a read only blueprint file containing the application code and everything it needs to run. So, all the dependencies. So, this container image is created. So, whenever we say application, and that means some code would be there. So, all that code along with all dependencies that might come from the OS, might come from other components of the system, libraries, OS and other things, all that is packed in, all that is bundled in a container. This is a read only blueprint file, right. So, this is also in a way is a file. So, it packs in all the application code and everything that is needed to run. So, that is container image is the first component of the containers. Then the second is container engine, right. So, container engine is a software, one example is Docker. So, container engine is a software that creates and manages the life cycle of containers, right. So, it is mainly responsible for creating and managing the containers. So, there can be multiple containers, that means there can be multiple applications, each one of them having their own dependencies, libraries and other configuration files packed in the container image, their own container image. So, container engine will actually be creating all those containers and managing the life cycle of it. Then the third component is orchestration tools. So, orchestration tools are actually systems, for example, Kubernetes that automate. So, the main function is automation of the deployment, scaling and management of large number of containers. So, when that application is to be run, so the orchestration would be done by the these orchestration tools like Kubernetes, which will automate the whole process of deployment, scaling and management of all these containers and therefore the applications that are contained within these, right. Then the fourth component is container registry. So, why container registry is needed? So, this is more like a storage system where which is being used for sharing and managing container images, right. So, it could be like a Docker Hub or Amazon ECR. So, Docker Hub or Amazon ECR, these are examples of container registry where we have all the information about different container images and they are shared through that system. So that we know what containers are available, and then we can use the orchestration and we can deploy them, right. So, essentially 4 components are there for container technology: container image, which contains the application code and all the dependency code configuration, then container engine, which will actually create the container from that container image, then orchestration, it will actually automate the deployment process. Deployment will obviously need computing and all that. So, it will automatically deploy, scale and manage all those aspects in terms of all the container that needs to be run, right. And then the container registry will have all the sharing of all the container images that are available. So, moving on, now what is the impact of containers on cloud, right. So, cloud, as we have been talking about containerized applications, when we were comparing the different cloud offerings of top cloud forms, then in that discussion we also had a point on container, right, containerized application. So, now here we are looking at the impact of containers on cloud. So, first impact is the portability, right. So, a container works, one important thing is it works just like it will work on a PC, same way it will work on a cloud server. So, therefore, that problem that we typically refer to when a particular application works on one machine quite well, and then a similar machine and we face a problem. So, we call it it works on my machine problem. So, that is taken away, because container is supposed to work exactly the same whether it is a PC or a server or cloud server, right, whether PC or cloud server, right. So, that portability of the application goes up manifold, right. So, that portability is one of the main benefit that you get from the containers, right. Then resource efficiency, just like virtual machines we talked about. So, instead of using a physical server, when we use virtual machine, our resource efficiency goes up. Similarly, in case of containers, we do not even need a separate OS. In case of virtual machine, we take separate OS, guest OS, right, and hypervisor sits in between the host and the guest OS, right. But here one additional resource efficiency can be achieved, because a separate OS is not needed for every app. So, more containers can be packed into a single server, right. So, from the same server we can pack more containers, right. So, therefore, higher resource efficiency can be achieved via containers. Then microservices. Now, microservices essentially is a move or shift away from large monolithic applications, and we are moving towards a design which is based on microservices, where modern applications in modern applications which are now microservices, they are following microservices architecture. So, a large app is actually broken into small independent pieces, right. So, a large application is broken into small independent pieces, and that is why we are using the term microservices. So, the smaller independent microservices are being created. Instead of large service, we are going for microservices. So, the large application is broken into small independent pieces that can be scaled or updated separately. So, because these are small, so scaling benefit can also be there, and the updation can also be done separately. So, overall, because things can be automated much easily in cloud setup, so overall efficiency gains would be there. So, containers are actually ideal to take advantage of microservices architecture, right, because of all the different resource efficiency and other aspects of containers that we have talked about. So, because of that, microservices architecture can be better implemented via containers. Then agile CI/CD. So, containers speed the way we can quickly deploy, create and all that things that we have talked about. Because of that speed, agile, which is a faster, agile and CI/CD which is a very fast way of software development. So, container speed is also a good match for automated testing and deployment pipeline that we see in agile CI/CD. So, more modern software development methodology, faster software development methodology in terms of agile CI/CD, that can actually be implemented via containers, right. So, these were some of the points in terms of impact. So, first one was portability and resource efficiency, right. In portability it can work on in multiple environments without much of issue. Resource efficiency is better because you can run multiple apps on the same setup, same server, microservices, smaller pieces, more scalable, updated, agile, faster development. Then we move to our next important question, right. So, we talked about the open source software transition, then we talked about the cloud transition. Now, we are going to talk about the app store app transition. So, what advantages do app store and apps have over packaged software and browser based alternatives? So, we will talk about this, right. So, first let us consider the app store. So, what is different in case of app store, we compare that with the packaged software. So, packaged software you will have to buy, you will have to download or buy in a CD form or DVD form or USB form or some physical form, or maybe download over the internet, that you will have to do. So, then browser based, the application itself will be loaded in the web browser. So, these two alternatives we have. In comparison to these two options, if we look at the app store, it is always accessible to end users, because app store itself is an application. So, you can quickly open that application and find, end users can find any app that they are looking for. So, this is always accessible to end users. So, that is a difference from packaged software, because in that case you will have to wait. There is a transaction cost and distribution cost that goes with the packaged software and the browser based software alternatives. So, this is one plus point, always accessible to end users. Then app distribution happens at a fraction of the cost of conventional packaged software, because in the conventional packaged software you will have to pay for printing disk or boxes and shipping. So, shipping costs can be used, disk and boxes, all that will also cost a lot, and then multiply that with the number of shipments that you are doing. So, all that cost is eliminated and only a fraction of the cost goes into managing an app store, right. So, obviously, the firm which is running the app store, they will have their own charging mechanism. So, therefore, cost would be there, but it would be a fraction of the cost of conventional packaged software. So, facilitates app distribution at a much lower cost. So, distribution cost go down. Then facilitates regular updating of apps in the background. So, this is again maintenance cost, this goes back to the maintenance cost. So, in case of traditional option, whether it is about the packaged software, then you will have to look for the bug fixes and you will have to download them, you have to regularly keep looking if there is any new bug fixing, new version released, maybe you will get an email for that, and then you will have to go to the website, download that, install, and hopefully think that it will work, right. So, similarly browser based alternative. So, browser based slightly better than package, that if there is any bug fixing, you go visit the website next time. So, it will be, you will get the latest version there, right. So, but in comparison to the packaged software, it is still better. So, facilitates regular updating of apps in the background, right. So, you can automate this update process. So, therefore, what you achieve through this regular updating of apps in the background, a quicker delivery of the latest features. You do not have to worry about being earlier there used to be a gap when a bug fix or a new patch is released or new version is released, and the time when it actually gets installed. So, during that period actually the older version or the buggy version will still be running, right. So, that is taken away nowadays because of the app stores, right. So, quicker delivery of the latest features, then better security due to quicker bug fixing updates. because background you keep on updating. So, more timely updates, so therefore, you are better protected. So, in a way better security, and because of all this lower software maintenance costs, you do not have to regularly check and update and do all that fixing. It happens in a slightly seamless fashion, because the app store will take care of the update process in the background. So, all these benefits are there, especially when we compare with the package software. Now, we come to the next that is app. So, we compare app with the other alternatives, whether package software or the browser based. So, this is more interactive. So, app interface is more interactive. So, more interactive than web based. So, that one advantage is there. Maybe package software might be more rich, because it is installed in your PC, much richer version, and but app typically we talk about the smartphones or other devices. So, it might not be that rich application, but it will definitely be more interactive than the web version, because the web version it has to be loaded in the browser. So, in terms of richness of interface, it will be the lowest, right. So, the app would sit in between packaged and web based. So, this is their more interactive interface than web. Then there is a OS level integration that we see in handheld devices. So, when we are talking about app store and apps, essentially much of our discussion is towards handheld devices, smartphones, and tablets. So, there in the the operating system, the Android or iOS that is there, the features, there are certain features that are possible because of the OS level integration in handheld devices. For example, apps can send direct messages to users, right, because the PC and other computers could be shared, right. So, you cannot absolutely make sure that the direct message reaching the user or not, but a smartphone and handheld, they are typically with one user. So, therefore, direct messaging and more the user would also be more attentive because of the mobility and portability of a smartphone and handheld devices. So, this direct messaging thing is possible, and then apps also offer location based services, where you can get real time updates and location adjustment, right. So, whenever we use Google Map or any other location based app, so whenever we are moving around our the path that we are taking, the route that we are taking, it will be updated if we make any changes there, right. So, real time update and location adjustment we can see. So, that those kind of services are possible with the apps, which are not obviously not applicable to desktop or PC environment. So, this additional thing in terms of feature that we see in case of transitions because of the apps and smartphones and handheld devices. Then next is portability, right. So, portability is there in handheld devices, right. While we are mobile, we can still use these devices, we can still use this form of computing. So, apps can capture impulse businesses, because you are at some place and you need some item, but if you do not have access to PC, you would not be able to buy. But nowadays, because we have access to smartphones, handheld devices, so that impulse purchases, that additional purchase can also happen, right. So, because of the portability, this is additional benefit that goes to basically to app based businesses, and then apps can facilitate instant payments, right. So, that is also if you have to do an online payment because you are carrying your smartphone, so you can do instant payment. So, that is also facilitated. So, we will stop at this point and we will continue our discussion in the next session. Thank you.